Now let's take the first question of this set. It says that an equilateral triangle BPC is drawn inside a square ABCD, and we have to find the value of the angle APD in degrees, right? So the entire system, if we draw, then it will look like this, right? I have already drawn the angles which will be formed. So let me explain it. So this is the square ABCD, and taking the side BC, a point will be there inside the square such that BPC will become a equilateral triangle. Now the moment it is an equilateral triangle, we can say that this angle will be 60 degree, this is 60 degree, and this is 60 degree, right? But since this is a square, this entire angle will be 90, so obviously this angle will be 30 degree, correct? Now since this is an equilateral triangle, we can say that all these lengths will be equal, so as this. And if you focus on the triangle, say APB, then here we can see that this is an isosceles triangle. Why so? Because AB and BP are equal, so obviously this is 30 degree, so both these angles will be equal. So if I assume them to be, say, x, then x plus 30 degree must be equal to 180 degree. On solving, we'll be getting the value of x to be 75 degree. The same thing we can do for the other side, that is for the triangle CPD, correct? Now clearly we can see that we have to figure out this angle. Now if I add this angle, say assume that this angle is theta, then theta plus 75 plus 60 plus 75 should be a complete circle, that is 360 degrees. So we can say that theta plus 75 plus 75 plus 60 should be equal to 360 degree, or we can say that theta is equal to 360 degree minus 150 plus 60 is 210, which comes out to be 150 degrees. So option D becomes the right answer. Not a very difficult question, can easily be solved provided we draw the diagram clearly, right? Now let's move to the next question. Now here it says that in the figure given below, AD and AE, they are 4 centimeter and 2 centimeter, 4 centimeter each, and BD and CE both are equal and they are 2 centimeter each. Now if BC is a straight line and the angle is given, we have to find the length of AB. Now if you just look at this figure, then we can see that this length BD is equal to CE. So both are 2 each, right? And the length of AD is 4. So as the length of AE, correct? And the angle ADE, this angle is 60 degree. Now we can see that this triangle ADE is already having two sides equal, so it's an isosceles triangle. Thereby this angle will be equal to this angle as well, so this is also 60 degree. And if you clearly observe, then sum of this plus this should be equal to what? 180 degree. So not only it's an isosceles triangle, rather it's an equilateral triangle. So thereby we can say that this is equal to 60 degree as well. And the length of D, please remember that I'm not looking for BC, I'm looking for DE. The length of DE should be equal to 4 as well. So the triangle is symmetrical, everything is symmetrical here because the triangle is equilateral. Now we need to find the length of AB. So obviously if I drop a perpendicular here like this, so that this becomes a 90 degree. So in the triangle AD, which is an equilateral triangle, this perpendicular will be the median as well, will be the angle bisector as well, right? So we can say that this angle would be 30 degree, correct? This is 60, this is 90, and of course this is 4, so this much portion would be 2, this much portion will also be 2. So applying Pythagoras theorem, we can get the length of AF. Let this point be F. So AF would be equal to how much? AF would be equal to under root of AD square, which is 4 square, minus DF square, which is 2 square. On solving, we'll be getting it as under root of this is 16 minus 4, which is equal to 12, or 2 root of 3, correct? Now this entire length, if you see, then this is 2 plus 2, which is equal to 4. Now we'll be focusing our we'll just shift our focus to the triangle AFB. This is also a right angle triangle. This point is F. Let me remind you that this point is F. So we have to focus on AB. So assuming that AB is X, again we can apply Pythagoras theorem. So here X square will be equal to this much length, which is equal to 4 square, plus the length, the altitude length, which we have already identified. The square of this will be nothing but 12. So X square is equal to 16 plus 12, which comes out to be 28. So the value of X will be under root of 28. Under root of 28 is basically 2 root of 7. So option A becomes the right answer. We need to find the length of AB, which is nothing but X. Again, I would say easy question, but you may require some time to get the answer. That usually happens with the geometry question. Now in this question, it says that in a triangle ABC, the length of AB, BC and AC are given. Clearly, if you observe that the square of this is 16, square of this is 9, and square of this is 25. And of course, we already know that 3, 4, 5 is a triplet, which is a right triangle. So we can draw the right triangle here. So right triangle would be something like this, whereby we can see that the length of AB is more than BC. So I should be drawing it like this. This length should be lesser than this. So this is A, this is B, this is C, this will be 90 degrees, this is 4, this is 3, and this is 5. Further say that D and E are the points on AB and AC. So on AB we are taking a point D, say this, and on point AC we are taking a point E, like this. And here it says that the angle BDC, BDC, so we have to draw this, is equal to ACB. So this angle is actually equal to this much. Similarly, BEC, that is this angle, is equal to ABC, that is 90 degrees. So obviously this is 90 degrees, correct? This is 90 degrees. So here we can see that there are a lot of triangles formed because of the cross intersection of DC and DC and BE. So a lot of similar triangles will also be formed. Let us figure out them. If we figure out triangle ABC, and if we focus on the triangle CBD, so here we can see that angle A corresponding is equal to angle this. Now why this angle is equal to angle A? It's very simple. This is 90 degree, correct? And one of this angle for this triangle is equal to one of the angle of the triangle ABC, correct? So thereby we can clearly see that the third angle will also be equal. So these two are similar. From the same concept, we can say that the other triangle would be triangle ABC, and that is similar to triangle BEC. Clearly here we can see that angle A will be equal to angle B for this triangle, right? Let me just mark it. This angle would be equal to this, correct? Because this is 90 degree and this is a common, C is common. One angle is 90 degree in both. So obviously they are similar. So these two pairs are also a similar triangle. Now if I want to figure out what is AD over EE, then we have to use both this relation to come to the conclusion, right? Now if I go for this relation, then we can say that AB over BC, that is this over this, should be equal to what? BC over BD. Now BC and CB and BC both are equal, so clearly we can say that BC square should be equal to AB into BD, correct? We have to figure out AD. So for AD we need to focus on BD, right? So let us take that BD will be equal to BC square over AB, right? Now BC is known, BC is 3, so 3 square is 9, and AB is 4, so 9 by 4. So we have identified that what is this length, which is nothing but 9 by 4. So we can find the length of AD, right? This length is nothing but what? 4 minus 9 by 4. So AD is 4 minus 9 by 4. So 16 minus 9 will be 7 by 4. So we have identified AD. Using the second relation, we'll be figuring out what will be the value of AE. Now to get the value of AE, we can get the value of EC. And once we got the value of EC, we'll deduct it from 5 to get the length of AE. So here again, we have to focus on BC, right? So we have to focus on this. And what are the lengths given? We have to focus on that also. So let us take BC over EC. This will be equal to AC over BC, right? Now we have to find EC. So clearly EC will be equal to BC square over AC. Now BC is how much? 3. So again it will be 9, and AC is how much? 5. This is 9 by 5. So clearly this length would be what? 5 minus 9 by 5. So 25 minus 9 by 5 is 16 by 5. So we have identified what is AE, and we have also identified what is AD. So clearly AD over AE, the value would be 7 divided by 4 into, here it would be 16, and we have to multiply 5 here. So it will be 35 divided by 64, which is option number B. A difficult one I would say, because we have to figure out these two relations first of all, and after that we have to figure out that what particular length we need to find. So obviously it's going to take some time, but I'll not be rating it as a too difficult, but it will be somewhere close to moderate level.
Now here in this question, we have been given that ABCD is a square with side 4 centimeter, and P is the midpoint of AD, as we can see here, and is joined with the vertex D. So PB is joined, and a perpendicular is drawn from vertex C on PB, and that point of intersection is E, and this is 90 degree, right? So we have to find the area of the triangle BEC. Now to figure out that this area, what we'll be doing is that we'll be joining PC. The reason we are joining PC is that we can easily find the area of triangle BPC. How? Because it's a square and this triangle is inside that square. The base of the square or the side of the square is actually equal to the base of this triangle, right? We are looking at the triangle BPC, right? Now here we can see that if the side is 4, then this is also 4, this is also 4. This length AB is nothing but exactly the height of this triangle, right? Both will be parallel and equal. So we can say that the height of this triangle is also equal to 4. So clearly the area of this triangle will be half base into height, which comes out to be 8, right? The entire area is 8. Now, since P is the midpoint, we can say that this is equal to 2, correct? We need to find the value of BP, which we can easily identify by applying Pythagoras theorem in this particular triangle, right? So BP square will be equal to what? 4 square plus 2 square. So it's going to be 4 square plus 2 square, which is equal to 20, or the value of BP will be equal to 2 root of 5. So BP is known, that is, this is equal to 2 root of 5. Somehow we need to find the length of CE, so that now we need to find the length of EC. For that, what we'll be doing is that we'll be applying the same logic that the area of this triangle BPC. There is other way of doing getting the same, is that if I consider BP to be the base, then this becomes the height, right? Say the EC is the height, then half base, which is 2 root of 5 into height, should be equal to the area, which is equal to 8. So clearly this height is nothing but EC, so we can say that EC would be equal to 16 by, in fact this will get cancelled. So straight away we can say that this is nothing but 8 divided by root of 5. So we have identified this length. 4 is already known, so we can apply Pythagoras theorem to get the length of BE. How? BE square will be equal to 4 square minus EC square, which is equal to 64 by 5. Correct? So on calculation we'll be getting, this will be 16. 16 into 5 is 80. 80 minus 64 is 16 by 5. So the value of BE would be equal to 4 by under root of 5. So this length is 4 by under root of 5. So this is the base and this is the height. So we can get the area of this triangle, which is half base into height. So height is 8 by root of 5. So clearly we can see that this will go out by 2 times. So this is 16 by 5 or 3.2. So option C becomes the right answer. Now in this question we have been given that there are two fixed poles on the opposite side of the road at a point A and B. The height of one of the pole is 70% of AB and the height of the other pole is 40% of AB. So let us assume that this is the road AB and assume that the height is 100. So one of the height is 70%, so this will be 70, and the other is 40%, right? So this will be say 40. Further, say that a point on AB is equidistant from top of the two poles. So there is a point on this which is equidistant from top of the two poles. So let us assume that this point is here. So what it's saying is that these two lengths is equal, correct? Say this point is P and this is A and B. So we need to find what is the distance of this point from the foot of the shortest pole. So we have to identify this length, right? So let me assume it to be X. So clearly this length would be what? 100 minus of X, right? These two lengths are same. So let me assume it to be say some value A. We have two variables and we have two right angle triangles, as you can see. We can apply Pythagoras theorem in each of these right angle triangles so that we can get an equation of two variables. So taking this triangle, we'll be having A square is equal to 70 square plus of 100 minus X whole square. Similarly, in this, we'll be getting it as A square, which is equal to X square plus 40 square. So what we can do is that we can substitute a square as this here to get the value of x. So we'll be getting, this will be 70 square, which is 4900, plus this will be equal to 100 square minus 2 times of 200 of x plus of x square, and this is equal to this much, which is nothing but x square plus 40 square, which is 1600. These two will get cancelled out, right? 100 square is 10,000. So on doing the simplification, I'll be getting 200 of x is equal to 10,000 plus of 4900 minus of 1600. Correct? On calculation, let me just remove 2 zeros from here. So this is 100 plus 49 minus of 16. So 149 minus 16, will be getting it as this will be 133, right? So the value of x is 133 divided by 2, which clearly is 66.5. So we can say that if AB is 100, we assume that AB is 100, then this length x is nothing but 66.5% of it. So option A becomes the right answer. Now here in this question, let's say that the triangle ABC is given and the angle ACB. So ACB, I'm just marking all this information given. This is 60 degree. And angle BAC, so BAC, this entire angle is 40 degree. Further, we say that AD is equal to AB. So from here itself, what we can do is that ABD is an isosceles triangle. So this angle, whatever it is, say this is theta, this will also be equal to theta. Correct? Now we have been given that CED, this angle is equal to angle ABC. We have already assumed that angle ABC is to be theta, so this is also equal to theta, right? Now, if you observe closely, then we can see that this much angle would be equal to 180 minus of theta. Why so? Because this is theta and this is a straight line. Further, if we pay attention to the quadrilateral ABDE, in this quadrilateral, we can see that this angle and this angle, they are opposite angle, right? And their sum, which will be equal to what? 180 minus theta plus of theta. This is nothing but equal to 180 degree. From this, what we can conclude is that this quadrilateral is nothing but a cyclic quadrilateral. A circle can be drawn like this, which will pass through all these 4 points, correct? And we have to find the length of angle DBE, that is DBE. So this angle we need to identify. Let me assume it to be alpha. We can say that this is formed on the arc ED. The same angle or a similar angle is formed on the same arc is EAD. So this angle will also be equal to alpha, right? Further, we can see that if this entire angle is 40 degree, this is 60 degree. So in a triangle ABC, if you just focus on a triangle ABC, this entire length, which is theta, is nothing but equal to 80 degree. How? Because the sum of 40, 60 and 80 should make it 180 degree. Sum of all the angles in a triangle is 180 degree. So straight away we have got the value of theta, which is equal to 80 degree. So if this is 80 degree, this is also say 80 degree. So in a triangle ABD, if you observe, then this is 80 and this is 80. This together will make it 160. So this much angle has to be 20 degree. And this is 20, this entire angle is 40 degrees. So obviously alpha is also equal to 20 degree, and hence this angle which we need to identify is also 20 degrees. So option C becomes the right answer. Now in this question it says that for the given figure, the triangle is right angle isosceles triangle. So AB and BC will be of same length, and the length is also given to us as 2. So both the lengths are 2, and there is a circle inscribed into it, and we need to find the length of BD, where D is the point of contact or the point of tangent. So it's going to be a very easy question. We just need to identify apply a simple logic that if a point outside the circle, 2 lines or 2 tangents are drawn, then both the tangents are equal, right? Let me just mark the point of contacts. So these are the point of contacts. If this is D, let me assume this to be E and this to be F. So clearly from A, 2 tangents have been drawn, AE and AF. So we can say that both AE and AF will be equal. Similarly, from point C, we can say that CF will be equal to CD. and similarly from BE and BD will be equal. So BD will be equal to P. Correct? Now, since it's a right angle triangle, this is 2, this is 2. So applying Pythagoras theorem, we can easily say that the length of AC is 2 root of 2. Just applying the simple Pythagoras theorem. Further, if this is the point, this is the center, if I drop perpendicular on AB, because AB is the tangent, then this will be 90 degree and this is the radius. Same thing we can say for this. So this is the radius, this is 90 degree, this is 90 degree. So this figure which is formed, that is BDOE, this is nothing but a square. So this is also R and this is also R. So we can say that AE, the value would be 2 minus of R. So this is 2 minus of R, and same thing would be for AF also. So this is also 2 minus of R. This is also 2 minus of R. And here also CD will be equal to what? The entire length is 2. This is R. So this is 2 minus of R, and the same thing will be equal to 2 minus of R. So here we can say that the sum of these two must be equal to 2 root of 2, right? So 2 minus R into 2 must be equal to 2 root of 2. So 2 will get cancelled out. So the value of R would be equal to 2 minus of root of 2. Now, which option we should be marking? So let us see that which option gives us 2 minus root 2. In fact, directly option B gives us 2 root 2, 2 minus root of 2. So option B becomes the right answer. Easy question, manageable question. Anybody who has a slightest idea about circle questions which are clubbed with circle and triangle should be able to solve it. Now here in this question, it says that there is a triangle ABC and the length of AB and AC is given. We need to find the length of perpendicular drawn from the vertex A to the side BC. So let us draw the triangle. It is something like this, wherein this is A, this is B, this is C, and the length of AB is 16, the length of AC is 9, and there is a perpendicular drop from A on BC. Say this point is G. So we need to find the length of AD, and the circumradius of the triangle, that is capital R, is also given to us. Now clearly we can find it by comparing the area of triangle or applying the formula of area of triangle in two different ways and comparing them. For example, the area of this triangle ABC would be equal to half into base into height. Right? This is one way of finding the area of this triangle. The other way, wherein all the three sides are given and the circumradius is given, we know that the formula is the product of all the three sides, which is AB into AC into BC divided by 4 times the circumradius. Both is nothing but area of the same triangle, so we can compare them. So clearly we can see that BC will be cancelled out, and we have the value of AB which is equal to 16, we have the value of AC which is 9, and we have the value of R which is also equal to 9. So we can clearly substitute here. This will also go out by 2 times. So the length of AD would be equal to AB which is 16 into AC which is equal to 9 divided by 2 into 9. So this will get cancelled out. This will also get cancelled out. So the answer is 8, which is option number C. Manageable question. Only if you know this formula, how to use it, then you can solve it within a minute. Now let's read the next question. Here it says that let P be a point on side AB of a triangle ABC, and there is a line drawn parallel to PC which passing through A and B meets BC and AC extended at X and Y respectively. And the lengths are also given. So the major challenge for this question is that can we draw the diagram by reading this statement? That is the major challenge, right? If you can draw it, then 80% of the work is done. So here you can see that this is not the part of the question. Basically this we need to draw. So here the question says, whatever the question says, you can just tally it on the diagram. It says that P is a point on side AB. So ABC is a triangle and P is this point which is on side AB, correct? And further it says that line drawn parallel to PC. So suppose this is PC and line drawn parallel to PC through point A. So this is parallel to this, right? And B also. So from B also we are drawing a parallel line to PC. They meet BC and AC extended. So if we extend BC and AC, they meet at the point X and Y. This is how we can read it. Of course, it is very challenging. If you can read the statement only and try to draw it, there is a chance that you may need it 2 or 3 iterations to figure out the exact diagram. Okay, let's move further. Here it says that if the length are given to us as A, B, and C, like AX is A, BY is B, and PC is C, then we need to find C is half of which of the following, correct? Now here clearly we can apply the rule of similar triangle. Why so? Because the things are given as parallel. For example, we can see that triangle, here we can see that the triangle say APC, this triangle would be similar to triangle ABY. Why so? Because this angle will be equal to this angle will be equal to this angle, because these two lines are parallel, right? So here their corresponding side, that is this over this, would be equal to this over this. Here again we have assumed that AP is X and PB is Y. So clearly we can say that X over C should be equal to X plus Y over B. Or we can say that X over X plus Y is equal to C by B. That may be question number 1. Now moving to the next set of similar triangle, which is triangle BCP. Triangle BCP, this will be similar to triangle BXA. Triangle BXA, right? Again we can see that if this length is y and this entire length is y plus x, so that will be equal to y over c. That should be equal to what? This entire length, which is equal to y plus x, or we can write it as x plus y also, x plus y divided by a. Correct? Let me just further simplify it in this way, that y over x plus y is equal to c by a. See, this is my equation number 2. Now what I'm doing is that I'm adding equation number 1 and 2, so that in the numerator I'll be getting both x and y. So clearly on adding this and this, I'll be getting x plus y over x plus y, and this is equal to c by b plus c by a. This is clearly equal to 1, right? Or we can say that 1 by a plus 1 by b is equal to 1 by c. Or we can say that c is nothing but ab over a plus b. If we simplify it, we'll be getting it this. Clearly, C can be written as half of, in fact, we have been asked about what is half of C, or C is half of what? Then C will be half of what? So we can say that C will be half of 2 times of AB over A plus B. Now this is nothing but harmonic mean of A and B. So option C becomes the right answer. Difficult one, of course, it is not expecting that we can solve it in an exam, but a very good question to see that how we crack the question by applying the multiple concepts. Now here the question says that a circle is circumscribed about a triangle whose sides are 16, 30 and 34. So we need to find the circumference of the circle. So we have to keenly observe these lengths of the sides of the triangle, and we can see that this is a triplet. Why so? Because it is nothing but 8, 15, 17. If I multiply these numbers by 2, I'll be getting 16, 30 and 34. And we know that this is the triplet wherein 17 is the hypotenuse. So this triangle so formed is something like this, wherein this length is 16, this length is 30 and this length is 34. So if I draw a circle like this, which is circumscribing this triangle, then we can say that this will be the diameter. So half of it will be the radius. So the radius r would be equal to half of 34, which is equal to 17. And we need to find the circumference. So obviously circumference is 2 pi r. So clearly the answer would be 2 into pi into 17 or 34 pi. So option B becomes the right answer. Very, very easy question. We just need to identify that this is a triplet and in which it will become a right angle triangle. Rest everything is very simple.